Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to provide an overview, an introduction to Unit 2, which is going to be talking about specifically numeric decision trees. So you can see here that we have 5 lessons in this particular unit. The first one is the overview, that's the one you're watching right now. Then we'll talk a little bit about data preparation, model development and model testing, you can see right here, and then we will conclude with modal tree development and testing, which is a slight variation on the ideal of numeric decision trees. So here we go, lesson 2.1. Now, excuse me for a second. You can see right here that regression trees have been around since the 1980s, so about 40 years now. And what they do is they predict the average value of specific examples that reach a given leaf on the tree. So remember, we talked about the difference between parent node, leaf, and trees. And so what's happening with numeric prediction trees is that you're trying to, as you go down the tree, predict the average as you split the tree. So splitting is based on the average, the mean of that particular group. Now this might be surprising, but as you can see right here, there's no regression involved with regression trees. This idea of regression trees, numeric prediction trees, they're all saying the same thing, but strictly it doesn't really involve regression. However, modal trees do use regression, and we're going to talk about that in the final lesson of this unit. Now, all the same algorithms are involved when you're doing regression trees or numeric prediction trees, whatever you want to call it. Now, the primary goal here is homogeneous groups, and that is determined not like by entropy as when you're doing classification, but rather by reducing the standard deviation. So as the standard deviation gets smaller and smaller, it indicates to the algorithm that the group is becoming more and more homogeneous. That is the primary goal there. Now, as with all algorithms, regression trees or numeric prediction trees, whatever you want to call them, have their strengths and weaknesses. So in terms of pros, regression trees are straightforward and they're easy to interpret. They're also able to handle lots of non-normal data. So if your data is kind of weird, regression trees might work for you. Also, model specification is not necessary. And what we mean by model specification is determining which variables to include and not include in the model. The algorithm does this for you, remember, because it determines what to use based on what shrinks the standard deviation the most. Now, in terms of cons, of course, this type of algorithm, it really struggles with large amounts of data. You can see that right there. And accuracy can be an issue because things are divided based on the mean, the average. And so whether, something to the left or to the right of the mean is kind of arbitrary, and that can kind of affect accuracy, or we could say another term for accuracy is, reducing the error rate, if you will, like the mean squared error or whatever. Of course, that's a tool for regression, but let's continue. And lastly, it's hard to determine feature importance. This might be related to the second bullet right here because there's a problem in terms of the mean, using the mean as a tool for splitting the data. And so when you're just using the mean, it's hard to figure out which feature, the word for feature is another word for variable, which ones are important, which ones are not important. Now, this feature importance becomes very, very important, no pun intended, when we get to random forest in a future unit. So this concludes lesson 2.1. And so in the next lesson, we're going to move right here to data preparation. So looking forward to seeing you there. My name is Darren Thomas, and I'm the Director of Educational Research Techniques.